So in this triangle, we're asked to solve the triangle below, giving side lengths correct to 2 decimal places, giving angle measures correct to 1 place of decimal. So look at the language here. Solve the triangle. Solve the triangle means find all missing sides and all missing angles. Okay, so that's the first thing that we have to realize. So let's look at our triangle now. We know 2 of the sides. We know one side has length 4 and the other side has length 9. We know we have a right triangle, but we don't know the hypotenuse and we don't know the other 2 angles. So you have to sort of begin with what we always do, which is labeling the 3 sides. So let's start with the right angle. We always start with the right angle, and the side that faces that is called the hypotenuse. And since we don't know it, let's call it x. Okay? And then we can't actually deal with the right angle. It doesn't tell us much apart from showing us where the other angle, where the hypotenuse is. But then we can decide that we're going to deal with either A or B. If we knew one of these, we would deal with the one we know. But since we don't know either of them, we get to choose which one we deal with. So let's say we deal with angle A. And again, that is a choice. It doesn't matter if you deal with B first, but we're going to deal with angle A. Okay, so if we deal with angle A, then we have to label the other 2 sides. Okay, so decide which angle you're going to deal with, and then label the sides based on that. So if we're dealing with angle A, the side opposite that is 4. So this becomes the opposite, and then 9 is the only side that hasn't been labeled yet, so that becomes the adjacent. Okay, so let's try and find angle 9. Okay, angle A. So if we're dealing with angle A, we know the opposite, which is 4, and we know the adjacent, which is 9. Okay, so if we know the opposite and the adjacent, the ratio that deals with opposite and adjacent is tan theta. So let's create an equation involving tan of our angle, so it's tan of A. So it always has to be, whenever we use sine, cos, or tan, it has to be followed by an angle. So in this case, the angle we're talking about is A. So tan is opposite over adjacent, so that's 4 over 9. And since we know what tan of A is, the way to find A is use inverse tan. So we're going to use inverse tan of 4 over 9. Okay? And if we look that up on our calculator, let's clear what we had there previously. Move this over here out of the way a little bit. And we want to use inverse tan, so second and tan of 4 over 9. 4 divided by 9. And that gives us 23.962. 23.962. 23.962 degrees. Now, if you were looking back up here, it said give angle measures correct to 1 place of decimals. So cut it off after the very first place of decimals. Okay, and a 6 is going to move that up, and it was 9, so it moves it up to 10, or this moves the next one up 24.0. So A is going to be 24.0. A is going to be 24.0 degrees. Okay, and we do need to include the 0.0 because it wasn't exactly 24, but the 24.0 shows that this is a rounded number correct to 1 place of decimals. Okay, so we've got angle A. Let's try and get angle B now. And remember, when you know the right angle and one other angle, it's easy enough to get the third angle. So the 3 angles have to add up to 180. So that would be 90 plus the A, which is 24.0, minus the B. Sorry, plus the B. So we add up these 3 angles to make 180. Now, let's try and move everything over to the same side. And that gives you 180 minus 90, which is 90. And 90 minus 24, which is B. So that would be 66 degrees. Okay, if you do that, that should work out as 66 degrees. I hope. or 66.0 degrees, I guess, to be consistent with what we had earlier. Okay, so 66.0 degrees is equal to B. Now, we've got two missing angles, but we also had to find the missing side this time, because we had to solve a triangle means find everything. So we need the missing side, and you can use trigonometry, but it's easier to use Pythagoras' theorem. Because if you know two sides in a right triangle, Pythagoras' theorem gets you to the third side quickly. So Pythagoras' theorem, remember, says the square of the hypotenuse, that's going to be x, so x squared is equal to the sum of the squares on the other two sides. So we're going to have x squared is equal to 4 squared plus 9 squared. Okay, so to find x, we're going to use the Pythagorean theorem. X was the hypotenuse, so x squared is equal to the square on each of the other two sides added together. So x squared would be 16 plus 81. So x squared would be 97. And x would be plus or minus the square root of 97. But we ignore the minus because we're talking about a side length. Okay, so x is equal to square root of 97, which is 9.8488. 9.8488. And if we look back at the instructions in the question, just to make sure, side lengths correct to 2 places of decimals. So if we're going to go to 2 places of decimals, draw a little division line after the second place, and the 8 is going to bump this one up. So it's going to be x is equal to 9.85. Okay, so we figured out how to find the two missing sides, and the two missing angles and the missing side as well. Okay, thanks again for watching.